Hey, so this video will be kind of like a highlights cut, condensed version of a live stream that I've done on twitch.tv/LiveOverflow. As you know, I've been streaming like the past few weeks, building an 8-bit computer. But in that particular stream, we went over challenges from the Google CTF 2019 qualifier. That CTF happened over the weekend and I played it again. And part of learning about security, is for me playing CTFs, but not only playing the CTF and getting frustrated and researching during the CTF, but the time after the CTF is equally important. Usually my video write-ups are part of that process of looking at challenges afterwards and looking at those write-ups and providing you those video write-ups. But also for me, I want to learn too, so I might often look at challenges that I tried but failed and want to see the real solutions. So during that stream, you will see me working through a few challenges. One challenge in particular, a challenge that hasn't been solved during the CTF, which was called Paste-Tastic or something like that. It's a browser client-side XSS kind of challenge. And we learn a lot about the same origin policy, how iframes interact with each other, and DOM clobbering. It's a really cool bug. And so I wanted to take you along the post-CTF review of the challenges and working through it as a way to learn from it and how that can look like. And so I think it was a fun stream, and this is something you should also do after you have played CTFs, looking for the write-ups and working through them. Either way, I hope you enjoy this highlights cut, and if you are interested in more streams, not necessarily related to security, but still talking about various different topics and building this 8-bit computer, then check out Twitch, which is twitch.tv/LiveOverflow. There you can also find full recordings of the live stream, but also on LiveOverflow 2, second YouTube channel that I started, which will be a bit more casual, which allows me a bit more free. So you can find there also highlight cuts of the streams. You can also find there in the playlists unlisted episodes of all the full stream recordings, as well as maybe some other casual videos that might happen here and there. Anyway, let's not procrastinate further. Let's head into the stream where we discuss challenges. Hello, everybody. Welcome back to the stream. Thanks for the bits. Kartoffel for Overflow. Okay, all right. So today, as you can see from the stream title, I don't plan to continue working on the 8-bit computer. This will be a thing, I guess, for tomorrow or so. Today, I want to kind of have like a post-CTF chat. So the Google CTF happened over the weekend. I played again, which felt good. Haven't played CTF in a while. And so yeah, I just want to take you along. Basically, this is what I would do now if I were alone. I would just look up write-ups, try to find write-ups, revisit some challenges, and maybe we can even like do this kind of together. Like maybe we, like you can help me maybe understand something if you have solved something that that I struggled with, or maybe I can tell you a little bit about how I solved something. However, okay, yeah, so that's the goal. All right, so the Google CTF happened over the weekend. The challenges are still up. I don't know how long these servers will stay available. So if you want to try it out yourself, maybe do that soon. However, Google is also generally pretty good at archiving those challenges. They even publish source code or instructions how to host those things as well on their GitHub at some point. So there's also an option for that. Also, they reward, I believe they reward write-ups, or at least they want certain write-ups for challenges because it was like a qualifier for the finals. So I'm sure there will be some really good write-ups coming out in this coming week. Maybe today, the first day, looking for write-ups is maybe a bit early already, but whatever. It's like we take what we take what we can get. Thanks for the sub, Uber 1337 mate. Volume is, oh, sorry. I had my microphone turned the other way. Is it now better with the volume? Again, congratulations to those top teams, Paste and Dragon Sector P4, but even here the others. Greg Rocket was really surprising. spam and hacks. It's incredible what these teams are doing. We got 15th place. I'm playing with Alice, which is really good, but I don't think that this is like my success here. So we solved quite a few challenges. I solved one challenge, okay? I solved one and I helped a bit with another, and all the other challenges I looked at, we never solved, or got failed and stuck at, okay? So results like this are often team efforts. Multiple peoples have been working on these challenges. So, you know, okay, so don't look at this and think that this was somehow my success. Did you try the Paste-Tastic challenge? Yes, this is another challenge that I spent a lot of time on. And this is one of the challenges I want to have a look at now, because it had no solves during the CTF. Somebody got really far, and we kind of chatted in IRC a little bit about the underlying bugs, or what is kind of abused there. And I had some of the ideas, but I was lacking some kind of information. So this is something that I'm not sure if I want to solve, if I will be able to solve this basically now on stream. I doubt so. But I kind of want to, there are a few things that I've heard about that I kind of want to explore and try out locally, just to see how that will work in theory without pulling off the whole chain, because it's like a little bit of a chain of things that you need to combine to fully solve this. IRC is used for the CTFs. Most of the CTFs, like the Google CTF, have an official IRC channel where you can contact and talk to the organizers and admins if there are technical problems. And after the CTF, the players usually just meet there and exchange solutions, ask questions. So being in that IRC channel is a good thing. You also get notified if something breaks or if a challenge has problems. So the IRC is generally a good place to be during this CTF. A lot of people still use IRC. By the way, oh yeah, we know that fact now. You're actually using IRC right now. Twitch chat has IRC as its backend. Just let you know, there is an IRC server, and you can just join the LiveOverflow channel on that IRC server if you directly connect to the Twitch IRC network. Anyway, okay, so I would say the first challenge I want to look at is the Paste-Tastic challenge. That was just kind of insane. There was a little bit of a write-up that I didn't, it was just a source code, didn't really understand it, so I want to explore that a bit more. Let's see, yeah, here, this is the write-up by Katie. So let's see a little bit also here what other people were writing about it. Okay. Paste-Tastic was one of the most fantastic challenges in 2019. I was aware that there's no origin check at handling messages event in window. Config can be removed by XSS filter, but couldn't come up with any more ideas. Yeah, I can also tell you how far, kind of like how far I got with it. Yeah, no, these are super old challenges. Okay, I guess there wasn't much discussion about it on Twitter. Let me show you a little bit what I figured out about this challenge. So when you create here a file, so you create the file, you get this file now, it has like a view URL. And if you look at how this is implemented, you see that this is actually loaded in an iframe. So there's a sandbox iframe where the content of this file is loaded. There's a bit of JavaScript going on. So if you load the view page, you can see that this iframe is not there. So the iframe is not there. The iframe is dynamically created by the app. So this is the JavaScript code. Why do you use Chrome? Why not to use Chrome? I'm an idiot. I need to copy this. To be honest, I don't care about the privacy. I have my mail at Google. My whole company is at Google. Also, so the web challenges like this might be also browser related. However, I mean, should have then also worked, I guess, on Chromium. Who knows? Like this was so I looked at this challenge pretty early off the CTF, right? So I didn't know how hard this challenge would be. And I made some pretty good progress that I will show you now. But ultimately, I wasn't like far enough to even solve it. I got stuck at some point. And then throughout the CTF, I realized nobody was solving it, and then realized, oh, this is a pretty tough, a pretty hard challenge. When it's such a hard challenge, it might be that it's a very weird browser quirk, something that just happens on that specific Chrome version or that specific Safari version. So browsers sometimes have weird quirks, and only people that really research that topic might be able to solve it, because they happen to have found these same quirks as well. So that's kind of like an assumption that you can have if you see such a client-side browser XSS or whatever challenge. When there are no solves, it must be something kind of obscure. It wasn't that obscure, to be honest, but I feel like I got some good. I was on a good track, but clearly I wasn't like enough to solve it in any way. Hi, Cold Fusion. No 8-bit today. We are reviewing challenges from the CTF that happened on the weekend. Okay, so yeah, so either you're on the create view or the view. So the view is the view where this iframe is created. So we can look at that function here, and you can see it gets some. There's a content ID tag. It gets the lines from there. It gets the data language also stored in there. Then it gets the viewer element. And then there's already like a differentiation between Markdown and not Markdown. And then also this viewer is then created, this viewer class is created. And then the rest is pretty, so it registers here a do report, function unimportant, captcha unimportant, and then it initializes the viewer, and then also it renders it renders the based on the language, it puts in the content and false. So it calls render on the viewer as well. And then populate recent is also unimportant, is for recent views. And so if we look at the viewer class, when it's creating, it gets this view container in there, and there you can see it creates the element. It loads /sandbox as the as a source domain path. It sets the sandbox attribute, and then it adds some like event listeners for loaded, and then it appends the sandbox iframe to the container, and then it also registers an event listener for messages. So messages can be used for iframes to communicate with each other, which is kind of an important point here. Then we know it calls init. On init, it then gets this sandbox iframe. Now it looks into the config, and it loads these scripts defined in that config. So you can see it like loops through the dependencies, and then it calls load script on this dependency. When that is done, it goes through all the preloads and also does load plugin on all the config preload plugins that are being done. Now, if we look at load script and load plugin, we see that load plugin calls load plugin and load script as well. There's just some housekeeping of the data. And then load script is very interesting because it gets the integrity. It fetches. So this is downloading that resource, that URL. I guess I should show you how that. So here you can see the config defined. It's just like a JSON or an object, I guess, JavaScript object with dependencies and plugins or something. Yeah, plugins here. And there's a integrity check. That's just unimportant. And the URL. So it downloads here that script. And then when it gets that script, it will call init script on the content window with script. And init script then calls eval inside of that sandbox window. Okay? So this is kind of important to understand. Now, of course, during the CTF, I was also looking at different kind of things. So, for example, could there be XSS in the recently added ones and all these things? What is otherwise still important here? Then I guess it's still important also this event listener. So init listener is being called when the sandbox here, when the viewer is created, and it adds an inside of the sandbox window, so inside of the iframe, it also adds an event listener for message, and here it checks the origin, and then it checks what kind of message this was. Was it a render message or was it a scroll message? And in the render message, then it just removes here things from the viewport. And here's again a check for Markdown. So it checks if the language is Markdown. If that's the case, then it will do inner HTML on marked of that data. And I found out that marked is a function defined by the Markdown renderer that this website is using. So they render the Markdown as like HTML, you know, just not the raw text, but they render it. And so they marked it and they turn the sanitizer on. So it should be safe HTML that is coming out there, and then it's assigning inner HTML. If that's not the case, it just creates a code element and puts the raw data in there, and it's all fine. And then it does a highlighting of that code. So here's the thing that I found out. I found that out through a bit of testing. So this is something I did. Let's create a new Markdown file, mark1, and then we can just like test this. We can do like a header. We can also do like a link. Okay, so now we have some Markdown, and then we can submit. So here's our text, and you can see it's not rendered. Fail. Why is it not rendered? Oh, I guess it doesn't render headers. It's fine. It rendered the link here. So if you look at the HTML it created, you can see that it created like an, I guess that maybe there needed a space between the, whatever, doesn't matter. You can see that it rendered the Markdown for a link as an anchor tag here. Oh, by the way, the goal of this challenge was kind of an XSS or stealing channel. You can do this DMCA here, and DMCA is reporting that data that pastes there now to the challenge administrators, the support people, and they will look at this. So this is also something that I explored. You know, you see the submit URL, you can submit other URLs, and then you see like the pingback, you see a browser accessing the URL that you are submitted for the DMCA takedown. So basically the idea is you create a malicious DMCA request, and the support person or the administrators clicking on it, and then they execute your exploit of the XSS and you steal some internal data. It's in cookies. No, this actually doesn't use cookies. This actually uses the local storage. So this just stores whatever you created in the local storage. So there's a recent, I think, sorry, you're right, sorry. I forgot. Right, the flag was in the cookies. Sorry, I totally forgot. There's a flag cookie that is set for us. It's a temp flag ABC123, which is a hint that the solution flag is also in the cookie. We need to steal the cookie of the person looking at the site. I totally forgot. Thanks for the. No, actually, you need the XSS protection in Chrome to make this exploitable. That's one cool thing about this challenge. You actually need to abuse the auditor in the case here. Like I said, there are multiple stages that you need to combine to make this exploitable. That's why it's so hard. And like I said, I doubt that we will solve this now. It's a bit too much of a setup, but there are some crucial things that I didn't know about that I kind of want to now experiment with. Okay, so now I show you also the one thing that I kind of found out and I thought I was on a good track, and that is an XSS. So there is filtering happening. So if you do like a script tag in Markdown, like just something basic like this, then and you submit that, and then you look at this, then the script tags are gone. So they are just gone. They are not there anymore. And I found out this, if you have a script tag at the front, then you do a second tag, and then you do a thing in the middle there, and you basically do also one in the middle here. And when you now submit it, then obviously this doesn't do anything because sandbox, but let me show you. There we go. I screwed up a bit the format. Yeah, so you can see there's an script alert now. Wait, script alert in HTML doesn't work anyway. Let me do, and this is basically about any tag. So you can do like an image tag, fake an image tag like this, and then src equals to x on error equals to alert 1, some other attribute, and then we can throw this here away. So I think this should work. So you see here the broken image. And you don't see the alert, but like I said, that's sandbox issues. I can explain in a second. So you see blocked script execution because documents frame is sandboxed. It doesn't have the allow scripts thing, but you can see here the image is now in there with an on arrow. So this is a bypass of the sanitizer. If you, we can also go here in the sources, and we go here in static in the app.js. And we look for, so this is the sanitizer here. So we can set like a breakpoint here. Let's reload the page. So there's a breakpoint now set here. So now, there we go. So EVT is the event that is coming in. Text, it's like an on listen event. It's this renderer message. It's like it's listening on, you should render this now. So this is executed inside of the context of the iframe. So you see this is our data that we passed in, script with the broken thing, and it has the sanitizer turned on, and the sanitizer is just replacing it with just stripping stuff with empty. Now we can execute that. We can also execute it like this. This is how this is basically how I tested it. Wait, I'll show you how I tested this. Marked is the function. So you can do marked of a string, of the string, for example, and then you need the options here. So now you can just, like, this is how I played around. This is how I found the bypass. I was starting out with just like image tag. Here's basically how I discovered this. Image source x alert on error alert 1. Okay, so we start this, right? This would be an XSS vector. So you see it's completely stripped. Then I tried what happens. So I was kind of inspired by the Google XSS, you know, maybe, I don't know how the sanitizer worked. I didn't look in the source code at all. So I thought, it's in a sandbox iframe and things like this. Let's see what happens with no script. Nothing happens. Then I thought, okay, when it's stripping, if it's server-side stripping, then something like this often works. Because it's not recursively stripping oftentimes. So if it strips away the script tag, then this kind of works. So it broke the image tag now, but it encoded the lower than sign here, LT. So I thought, that's weird. And then for whatever reason, I placed another script tag in front of it, and suddenly it turned into a full image tag. And so that's how I found the bypass, basically. Okay, so now we have XSS execution theoretically in the sandbox iframe. We found a bypass of the sanitizer of this library. But it turns out, I believe this is actually completely not important for the solution. I believe the solution, so the write-up by Katie was also not complete. So this solution only worked locally. It didn't work remotely. That's why this person didn't solve it during the CTF. It has 0 solves during the CTF. So I'm not quite sure why it's not a full solution, but like I said, I'm not sure if I would solve it now anyway. It's more about exploring some of the concepts I didn't think about or realize. So yeah, so I thought I was on a good path. This is kind of how far I got. And then I thought about if you can somehow, you know, make that sandboxed iframe still be able to execute that. But the problem is it's not a reflective XSS, right? It's a DOM XSS. It only happens because the view page is embedding the sandbox iframe, and then it sends a message to render that in the iframe, and so that just didn't work. Okay, so now we come to the part that I'm interested in, like what kind of is the solution. So now let's look a little bit in the files that this person has uploaded, because there are some really weird, interesting things here. This was another thing, you know, maybe they were trolling and they were actually wanting you to exploit a browser ODA. We had these kind of challenges before, or people solved it that way. Anyway, so if we look at this person's exploit HTML script, we see that first of all, it iframes. Okay, so you don't see it, it's behind my face, but this is an iframe and this is the URL of the iframe. And the URL of the iframe is a view URL. But the interesting part is after the view URL. So here the view ends, right? This is the whole view URL to the left of it. And then there's a fake XSS parameter containing the the config variable. So if we just copy and paste this here, oh wait, we can do it ourselves. So basically what the person has done, so this is the website, right? Basically the person has taken this config JavaScript, this variable in the JavaScript, added a fake parameter. That parameter does not exist, right? It's like anything, ISD, whatever, equal to this. And see now how it turns red. That's because the XSS auditor, the thing that is supposed to protect you from XSS, is in this case configured to just block the malicious script. The site still is, it doesn't block the whole website and stops you from going there. The only thing it does is it blocks that particular config script, okay? This is a crucial step that I actually a little bit thought about this. So as we know from the JavaScript, it uses the config in the init to loop over the dependencies, and then in the end it ends in an eval of that script inside of the sandbox. So if we could somehow change the config variable to contain a malicious script from us, then that malicious script from us would then be injected into the sandbox and then evaled in there, which then would have access to the cookie, and our script could then steal the cookie. So that was one idea I had. And there is this idea of DOM clobbering, but there wasn't a way how I saw how to execute this. I also didn't think of disabling the config itself. I was just thinking of DOM clobbering. So what's DOM clobbering? There are two links. One has an ID X and a name Y, and then suddenly there are JavaScript variables with the name X and Y. So because this href has an ID X, you can access this just with the variable X. And so you never created that variable X. Just because you included that in the HTML, suddenly there is this variable in JavaScript available. And you can use this to kind of set variables in JavaScript that shouldn't be set, or you can override sometimes stuff. So this idea of that the HTML tags with certain attributes clobber or poison or influence the JavaScript variable space is, one of the attack ideas. And so I thought about this, obviously. Like I saw that in the code it would take the config to take those URLs and execute these. So if we could somehow change the config, we could execute our own stuff. And how do you influence a variable in JavaScript? Either you have a full XSS, then you could just, by that I mean just some JavaScript context where you can set a variable, for example. This is a way how you could maybe change that. But obviously that would already be very powerful. And the other option would be that maybe we find an injection that doesn't allow us to inject JavaScript, but it allows us to inject other HTML tags, and then we could use those properties to still influence the script execution by giving it a name and an ID. Even though we don't have a full JavaScript XSS, we still influence the script execution. That kind of was like an idea. I wrote that down in our CTF notes as maybe clobber config or something. Wait, I can read you exactly what I wrote down. Really proud of that, as you can tell. So I wrote down, other attack idea could be clobbering config somehow. This could trigger an unsafe eval inside of the sandbox iframe to leak the cookie. But we would, and I added, but we would need at least an HTML tag injection in the view page here. So that was kind of an idea I wrote down. It seems to have been part of this, but one crucial step was that you first need to disable that variable. You need to make the browser delete that config variable, because so when we loaded this page with the fake, so the XSS auditor was triggered and we inspect the console, we see the error message. So the XSS auditor refused to execute a script. It thought that our injection with the config was injecting those variables. It obviously didn't, but it caused the browser to strip away that config variable now. And now you can see that the script fails because it can't find config anymore. Config is not defined. Config doesn't exist now. It doesn't exist anymore. And so now the idea is, if you are somehow able to now get like a tag in there with this config variable, then suddenly this variable would exist. Yeah, it wasn't solved. There's only a solution that seemed to have worked locally but didn't work remotely, so it kind of contains a lot of the solutions. But wouldn't it still be blocked because of the script tag? There's no script tag right now. Okay, so I know this is like really it's a mind-bending challenge. There are a lot of different moving parts that are kind of influencing each other, and the whole exploit at the end, the whole attack, will be a chain of multiple weird browser behaviors. Okay, so I have a hard time wrapping my head around this. I'm not even sure I can. Like I said, I'm not sure if I could even solve this now with those hints. But there are a few browser behaviors that I want to explore now that are part of the solution. And one part was here to abuse the XSS auditor to disable the config variable. So this is one puzzle piece that we have now, that we are able to abuse the XSS auditor to disable or to remove the config variable. So now the site is broken, doesn't have a config variable. This is the whole dilemma we are in. This XSS auditor is a curse. So either it blocks your website entirely. If you watched my videos about the XS leak, it was a challenge at the C3 CTF. So either you have the browser blocks completely the site, then it can be abused for an attack called cross-site search leaking, which is bad. There was a CTF challenge I made a video about, so you can watch that if you don't know what it is. Funnily, that challenge was created by a Google employee. So like Googlers know that this exists, right? They are in a dilemma here with how should their browser behave. So we have cases where blocking entire sites with the XSS auditor can be abused as an attack. So now the question is, what should the default be? Let's just strip the scripts. But this is also a known attack, because stripping certain scripts allows you to influence how the site behaves and opens up attacks like on this CTF challenge. So this CTF challenge is an example for how stripping away certain parts of scripts can influence the web page and possibly lead to open up attacks. So now we have both options somehow lead to an attack. And completely having no XSS auditor is also, I guess, so this auditor trick is required because DOM clobbering won't override an existing variable. I believe so. So here's the thing, like where I have somewhat like heard about these things, but I'm also not sure. This is like what I'm here for right now. I kind of want to explore these and test these things again to build that experience and that knowledge about how this exactly behaves, because these kind of precise questions that you were asking, Alex, are exactly the things that you need to know if you want to solve a challenge like this, right? I just knew that there's clobbering, but I didn't know exactly the context of it. So now is a good time to explore this, basically. That's the idea. So I also don't know right now how you get the clobbering into the view page, right? But the script above here is supposed to do that. I'm really not quite sure. I still don't know. Maybe I need to draw this open, because there are multiple pages now involved with iframing each other. It's and sending messages around. It's like crazy. So this person here, this exploit script has an iframe, and it iframes the view page. And now it goes into that iframe, into the content window, which is a different domain. So this is cross origin, but you can still access the window of the cross origin. And I didn't know that you can access the frames and change the location of that frame. I didn't know about this, so this is something I want to test out. Is it not in violation? Why is this allowed, or is this just allowed? Is there some special case where it's only allowed, or is just a case like you can access you can iframe a site and you can access the frames that this frame included, but you are not allowed to access the content. I know that the location of iframes in Windows, this is a property that you can write to. So you can force a redirect of a window that is not on your origin. You can't access the content, but you can redirect it. So my assumption is, and that I didn't know, that you can follow this chain of windows and frames down to whatever and then change the location of that frame. So, and apparently that you can do. But And then you change the location of that frame. And then when that is loaded, now it changes the name of the frame. And this is where the clobbering, I guess, happens, because here's now the name config assigned. And my assumption is that you are allowed to change the name of the frame because the name is your domain from which this exploit is loaded. So at the top, you have your site that iframes the view. That view has another iframe. You redirect that bottom iframe to your origin. Now both the top domain, then there's the middle view, and the bottom domain is your origin. And now you can change the iframe name of that your origin. That's at least how I imagine it right now. We need to verify if that thought is true. And now you can change the name, which then causes a DOM clobbering in the middle page of the view, which changes then the config variable. That's kind of how I imagine it right now, but not quite sure. So we need to review that. It's like mind bending. We might need a paper to draw that to visualize this. It's like crazy. And then there are a few other scripts that I don't understand in here. So this is one thing that we need to do. The exploit py is just a server that serves the data. And then there's this inner HTML here. Wait, what does he load again? He loads, so the bottom iframe is loaded to ginner now. And ginner does what? It just iframes viewer again. Like, wait, if he iframes viewer. Okay, yeah, I have no clue what's going on. Okay, so I don't know why it does that. And then there's this helper markdown, which is an image tag with this JavaScript, which I don't know what this is. I believe that's just to make sure that this script exists already, that it doesn't have to be downloaded first, basically to not wait for it, but that the browser already has it in its cache and can just serve it immediately and execute it. That's the only reason why I believe this is used, but really not sure. And I believe the inner iframe, the iframe that this ginner HTML is loading, I believe would then be that markdown to make sure that this script is loaded. But I'm not quite sure why. Yeah, we have that script here, and that script here, that is then the actual leak. So I'm not quite sure how this, this JavaScript might be then, wait, paste exploit. Oh yeah, wait, I think I got it now. That should be part of the config now, right? So if we look at the config, that it's config frame name. I'm not quite sure what the value of this config is then. Like, I guess this becomes clear once we look at how an iframe clobbers the JavaScript, like how the, oh, I get it now. I think I get it what the markdown is for. This will create two headers with that ID in markdown, and I believe that will then be part of the config.plugins, config. And so this is the way how you can construct that config variable object, that it looks correct, so that then it can load that script. I believe that's how it kind of works. So how are keys and values set exactly? I believe this is the key moment. This is where it uses the markdown, because I think the rendered markdown headers will create like an ID automatically if you render this markdown. I'm not sure how GitHub renders this, but so it creates these headers and or these anchors. And so I believe maybe the markdown renderer on that page creates IDs that match the name, so dependencies and preload and plugins. And then plugins is a link which has then an href. Yeah, that somehow, that must be it, but we will explore that. I think now I've understand this chain, but yeah, we will explore that in a second. We go step by step and first explore like this clobbering, I guess. So we continue trying to understand this. I just need to run really quickly to the bathroom. I will be right back in just a minute or so. And then we create experiments locally and test out these few assumptions to be able to understand the puzzle pieces that make up this whole solution. Okay, so I will be right back. Welcome back. Thanks for playing. Yeah, the flag and message are still left over from the charity stream from the blind hacker. I have been on there as a guest. That's why I included that message. So if you haven't seen that yet, you can go to the blind hacker Twitch and look at the VOD. I spent like an hour explaining basics of electronics and failing. That's also something that we explore tomorrow. Why I failed with what I was showing there, in case you're interested. Let's do this. So how do we test this? Step by step. We have multiple. Okay, wait. How do we wait? I need a piece of paper. 1 second. And the first thing, just like clobber in general. Organizers didn't reveal how to solve it. Actually, yes. So wait, this is also kind of interesting. So the challenge author, I believe, or at least who at least knows this. So after the CTF, you can chat with people in IRC, and people have you can ask them. So and they will release a solution at some point, probably for sure. But there was a discussion. I'm not logged in, and I can't look at the tweets and replies. God damn it, Twitter. I jokingly, so during the CTF, because okay, so at the Congress CTF, at CE3 CTF. There was also this web challenge that I made this video about, the XS League, the Cross Search League challenge, whatever, which you can find on LiveOverflow. That challenge was actually about a bug that was discussed on Twitter before. And I jokingly said to my teammates, I'm so frustrated, I might just start reading all the tweets and responses and discussions from all the XSS and browser researchers that I know of on Twitter for the past year and try to find things that could help. And indeed, there was a discussion that was part of solution. Now let me quickly try to find this. It just takes a moment. So XSS Auditor's default mode is now filter mode. Filter is this where it just strips out certain parts. You can remove scripts that you don't like, make variable defined in one script block undefined, and more. What could go wrong? So this is this config part about abusing the XSS Auditor. And now, Eduardo added, you can also do DOM clobbering attacks on defined variables by undefining them using the filter. This, again, is exactly this part of this challenge here. You enable DOM clobbering. So the mitigation for DOM clobbering is that you define those variables, but you can now undefine them, and now you open them up to DOM clobbering. And they wrote about this in April. But at least this is going to die in Chrome 75. Oh, Chrome's so bad. Why do you use Chrome? At least for DOM clobbering using cross-origin iframe. And so I believe this is kind of the hint that there is a thing going on with cross-origin iframes and clobbering the DOM and doing that name trick that we saw in that exploit that we need to explore in a moment. Cross-origin, but the texts usually are with same origin iframes, aren't they? Yes, most of DOM clobbering requires some DOM element injection, except one, which is going to die soon. This person is not really, you know, like, I don't know, not quite literally saying what it is. You mean iframe? Yeah, you mean iframes, but the texts are too direct. But their texts are to direct them to same origin iframes, not cross origin. Is that what you mean? This is exactly what we see in that write-up, right? The iframes, you redirect an inner iframe to another origin, or to the same origin, to your origin in that sense, and then it enables that clobbering, which I wasn't aware of. I'm thinking more like a Boolean true instead of that. Yeah, and then they talk a little bit other stuff. So yeah, so this discussion in April was a crucial part. Okay, so let's test this. I want to see this. I want to kind of like understand how this works. So how can we test this? We just create test HTML files. Okay, so I just wanted to quickly test the clobbering in general. So we can do, let's do a script tag here. Let's do here console.log of a variable called, I guess we can call it already config just to test with this. And now we test this. To test this, we just go into the terminal, and so we get a server on localhost, I just noticed the default serving is on is on 00. It's not localhost. How can I do this? Can I do like this? It's bind. Okay. Here we have our test page. Config is not defined. Makes sense, right? So that now the DOM clobbering, I forgot, is it the name or is it the ID? So if we define an ID, does this enable DOM clobbering? Cool. Okay. So the variable config is now just referencing that element. So let's see. Name, does this have the same effect or is this just no? Okay. Was name then the effect of the property? Okay, so you don't do this via the name. Frame name, I guess. Okay, wait, the frame name is maybe different. Ah, wait. I believe, oh, it might be children, right? So if I have like, let's say I have a div. Can I div ID inside? No, okay, I'm a noob. Okay, this is not how it works. But yeah, our goal is with iframe anyway. But iframe then, it was not ID, it was name of the iframe, right? Ah, this gives you the window of the iframe. Interesting. Wow, okay. That's why this also works. Okay, so this gives you the window, and then window dot something is stuff inside of that iframe. Oh wow, that's really powerful. So you can use the source doc to just define something inside. So we can do div ID x, for example, inside of the iframe. Okay, no, that didn't work. Okay, so config is the window. Oh no, it worked. I don't know why config. Oh, maybe the source doc wasn't loaded yet when the page loaded. Okay, yeah, so this is how it works. Wow, okay, so see how we created this variable now through an iframe that contains a div with ID. There's no like implicit ID, right? Or is there such a thing? I don't know. All right. when I do stuff like this, like client-side browser, I question like everything that I know about browsers. I might ask the dumbest HTML questions just because it's so quirky. GG, now get the flag. Okay, yeah, cool. Okay, so we understand the DOM clobbering part in general now. Yeah, most likely. Okay, so let's say, like this website, and it's an object with X on it, like that. Maybe we do a set timeout just to make sure the source doc is loaded. Okay, so now it returns la. It's our X object. It's our config object. The DOM clobbering didn't work. But now if we include this in a fake XSS parameter, here's something I noticed about the XSS auditor that I found quite, because I also thought about, I played around with this a bit. So just like this, it is not recognized as an injection. Even though it's exactly the text of our script, this doesn't block it. It only blocks it if you add, for example, the closing tag to it. Okay, no, that didn't work. Oh, no, yeah, it stripped it. Okay, it worked. Is it only on Chrome or works on Firefox too? I would assume that this is the same, that this behavior is standard. That feels like standard. It doesn't have an XSS auditor, so there's that, but no, not take a screenshot. No, now it doesn't have an XSS auditor, so this is here, this particular tag doesn't work in Firefox like that. But the DOM clobbering in general works. So you can see that that we also, with the iframe, we clobbered the variables. Firefox doesn't have an XSS auditor. Okay, anyway, so we kind of understood clobbering. Now this iframe thing about the cross-origin thing, this is what I'm really curious about. To test cross-origin now with Chrome, here's how I do this. I get a second terminal really quick. And then we add, I guess I need sudo maybe? Ah, crap. So basically, I want to add two fake domains that are both localhost. Let's say example.com and evil.com. So these are our two websites that are now accessible via localhost. So let's create a new script. We call that 2.html, and we create 3.html. And then you can do evil.com/3.html. Okay, this was fail. I guess Chrome didn't honor unique IPs. I believe I've tested this before with the Chrome, the web, the layer, like the web layer doesn't care about the IPs behind it. That is an origin is defined based on the host name here. This is completely irrelevant what IPs are there. Oh, I'm an idiot. There we go. Port 8000. We were hosting. Command engineer, you were saying server hosting on IP. That reminded me that we did it on port 8000. No. Okay, so now we have basically two different domains that we can test this iframing with. First of all, example.com. Okay, let's make another harmless, just like a random. Well, let's call it maybe 2_1. Okay, so now let's see. The idea is now, the attack idea is that we want to clobber the config of this page here. We can't directly do this because we have no injection here. But what we can do is we can iframe this page inside of from our evil domain. Like evil is just our website. We can control this. So what we do here now is we iframe example.com the 2. Okay. So now our evil website is iframing example, which iframes itself. And now let's see what we can do with this. So now we are, so if you didn't know, in the JavaScript console, you can say, you can define in which context you want to execute JavaScript. So if you want to execute this on the on to.html, so this is our example page. Obviously there exists config. Okay, so this is the HTML world of that one. But our top, this is our website that we control, and there's obviously no config. Okay, so but now the idea is that document.frames, no, window.frames. Okay, so frames. So there's the first. We get our iframe. So this should be the first iframe. Can we access its location? No, we cannot read the location, I believe. Or it's just, okay. So we are not allowed to read the location. Why is this important? I don't know the historical reasons, but I believe the reason for that is that sometimes websites include, for example, the session token in the parameters, or in general, sometimes there's secret stuff in the parameters that you don't want to leak. But if you could iframe another site and then read the URL, you might be able to steal that from the URL, right? So it's important that the same origin policy prevents us from reading the location, the correct URL of the. I believe that's how I explain this to me. However, it's writable, so we should be able to assign a different page to it, and we can redirect it, for example, to http evil.com port 8000 slash. Let's make also another evil site here. So 3_1. So if we do this to 3.1 HTML, then this should work. So we are allowed to redirect that page. We are just not allowed. We are allowed to assign, but we are not allowed to read the location. Okay, cool. So now apparently what you can do is from inside of that frame. So window. Okay, yeah, it is already the window object. You can access its frames apparently. So now this should be theoretically the child frame. So we do this twice. We go the frames down. Yeah, okay, so now we redirected, as you can see, we redirected the inner iframe. So this is allowed. And so now let's see. If we would try, okay, so this is the one code. So we need to remember this. Okay. So the next thing is, are we allowed to change the name of this iframe? No, we are not allowed to modify the frame's name because cross origin. But which origin? Is it blocked because of the first layer here? Because this is the iframe, so we access the iframe of this layer, or is it because the child iframe that it belongs to is not allowed to change its name? So the idea is apparently now if we change the location to our domain, now this inner child and our outer thing is the same origin. So this outer should be allowed to access the inner frames document. So see how children, see how we are allowed to, so you are not allowed to access the children of the, so this window, oh my gosh, I hope this is not too confusing. So window is our evil side. Frames 0 is our example.com. So if we would try to access the document of the site that we have iframes, so example, that is blocked by the same origin policy. But example.com now iframes our domain again. So frames of that is allowed. So we can access our own domain content. So we can access inside of there. And now the idea is, so after we change, we redirect the inner one. Now we should be allowed to change the name to ASD. And that should be, this changed now the name. And now if we go inside of example.com, so now we are in the context of example.com. So in here we have the config, if you remember. If we access now ASD, we access the frames name. Through that we clobbered now the variable JavaScript space of example.com, even though we have no direct access to it. And so now it makes sense, right? If we DOM clobber config away, so let's say we are iframing, let's see, wait, we need to be able to clobber that away. So let's go here again, take this whole thing and add that as an XSS. So now the XSS frame blocked the config. So inside of example, so we changed the context, we are inside, there's no config now anymore. But if we now execute basically the attack, we change the location, we add the name config. Now, if we go on this site's button, okay, it doesn't do anything. Okay, wait, maybe we did the handler wrong, the click handler, but doesn't matter. So now we are in example context, and now there should be config again. So config exists now again. Isn't that cool? Cool. Okay, so this is awesome. So what we just learned is how that we can clobber variables. That was fine. We can use the XSS Auditor to disable variables that were already set, and we can abuse nested iframes, which we redirect an internal iframe to our domain. Then we can access the name and we can clobber the context. So now for the CTF challenge, that means we can iframe a view. We can redirect the inner iframe to our domain. The iframed view needs the config to be disabled by the auditor. We then change the name of the iframe, which clobbers the config. And then comes this other part of the challenge. To trigger the re-rendering, you need to be able, and that's, I think, the other thing I need. Crap, I closed Sublime. And so if you look at the code, so render, so there's this renderer. The renderer sends a message from the content window, a post message, to render again. And then we have this on message handler, which is here. It receives that message. It removes its child ports. Oh no, this is not what we want. This is not the re-rendering. I believe, oh yeah, I believe it's triggered on an error. So if the parent receives an error message, so if the child iframe, like the sandbox iframe, sends an error message up to the main page, then it will init and load the plugins again, and that will trigger the looking again at the config and loading those scripts and then executing them. And how do you trigger this? So this was the other thing. It just is an event listener for message. So I believe, so we can test this, I guess, really quick. Can this site also be accessed? The idea would be, let's go to our, I guess here. Let's make a new one. Okay, yeah, so this is the next point. So post message. Oh, thanks for the Twitch Prime TPG stream. Okay, so we Paste-Tastic. Okay, so Mozilla post message. I forgot how to do post message. Or I don't. I would just want to copy and paste it. Okay, so this is that window, and now on there is a post message, and then the first message. So if we basically, I want to test out sending that error message. So we need an event object that has data, that has a type, and so now we go into the sources of the Paste-Tastic website, app.js, and we set a breakpoint at the message receiving. So let's trigger this again. Doesn't do sheet. Do I need the origin? Okay, so wait, I would then add the origin. So the origin would be oh yeah, okay. Wow, okay, so now we are in here, and then we can okay, so data is exactly what we came in. So this would now execute init and load script. Okay, so this is how we can re-trigger this. So if we, just as a test, I'm overriding now. Config is still like fine, right? Config is our variable. We didn't do any attack on here. I just want to replace it with something else because it will trigger some errors, I assume. So if we let this run, yeah, cannot read property 0 of, so this triggers a re-rendering and then fails when it wants here to access the config.viewer. So this is how the evil side can after all the clobbering is done and the changing of the iframe, it can re-trigger the rendering now. Loading the plugins, the loading of the plugins would download your script, would eval that script inside of the sandbox, and that eval sandbox can then, is just a script, can then send back the cookie. This should be the whole solution of this challenge. I'm curious, why does this not work, this exploit then? Because based on all of that, all of this should have worked. I'm really curious why apparently this has not worked. Or why this has only worked locally while Katie wasn't able to exploit it. But yeah, this is good enough for me. No, it's good. It's okay. Oh, they finished 30 minutes late. Ah, okay. Awesome. Okay, yeah, cool. So I'm quite satisfied with that right now. I might want to just like execute the full exploit at some point myself, but I wanted to take you along a post-CTF kind of way. Like, you know, you play the CTF, which is great. You learn during the CTF, you explore stuff and you get stuck. And this post-CTF is equally as important to revisit the challenges that you failed at or that you're just interested in, and then looking at write-ups to various degrees, however you feel like. And so I feel really good now about Paste-Tastic. I feel like I completely understood how this challenge has worked, and I got now the experience of these couple of like tricks that were abused to make this whole thing work. And so this is how I basically feel now very confident about this particular challenge, right? So this is, so I did now my part of the post-CTF write-up thing for this challenge. So I'm quite happy with that. Anyway, the recording of the stream is as always available on Twitch. You can go up in the tabs on videos if you have joined later and you want to see how we have been working through some of these challenges. You can just check out the recording. It will also be made available in a more condensed version on the LiveOverflow 2 YouTube channel, where there are highlights uploaded of the Twitch streams. Actually, this post-CTF talk, I might even upload this to the main channel just because it is relevant to the main channel. So I consider doing that. Yeah, thanks so much for hanging out with me. Thanks for also playing, I guess, the CTF. Good job. And see you then tomorrow for another, probably tomorrow, probably also again in the later hours, similar like today, hopefully maybe a bit earlier, who knows, no promises. But we will continue building the 8-bit computer, which we have neglected today. So thanks so much, and see you tomorrow. Have a great evening. Bye-bye.